Yeah, the whole idea behind literal equations is to express one variable in terms of other variables and numerical values. So looking at this, we have an equation a squared plus b squared equals c squared. We're required to find the value of a when b equals 6.0 and c equals 6.5, and then we're required to make a the subject. Now this question doesn't make a lot of sense because if we make a the subject first and then substitute the values, we can get the value of a immediately. So we're going to start with b first. Part b. So a squared plus b squared equals c squared. Now we want to make a the subject. A isn't quite a, it's a squared in its present form. So any term that does not include an a, we will then just move across to the other side, right? So what we're doing with literal equations is we're essentially performing reverse BODMAS. So where we are adding, to reverse addition, we subtract. To reverse multiplication, we divide, etc. So we're taking the b squared across to the right-hand side. So we've isolated a squared, but we need a, not a squared. So to isolate a, we're now going to square root both sides of the equation. What you do to the one side of an equation, you have to do to the other. So the square root of a squared is a, and on the right hand side we have the square root of c squared minus b squared. Now under no circumstances may you square root over a plus or a minus sign. This is the answer. This is most certainly not c minus b. That is not the case. You cannot square root over a plus or minus sign. So a is now the subject of the formula. Now to evaluate a when b is 6 and c is 6.5, we're now just going to substitute these values into what we've just determined. The expression we've just determined. So we have the square root of c is 6.5, so we have 6.5 squared, minus b is 6.0 squared. And then we can just plug that onto the calculator. A equals 5 over 2. At this level, stay away from mixed fractions, mixed numbers, and decimals. They are not necessary, they're messy to work with, and they are not high school level. So leave all your answers as improper fractions. A is 5 over 2. Here, S equals UT plus a half AT squared. So as it is right now with this equation, S is the subject of the formula. It's expressed in terms of the variables UT and A. Okay, here they want us to find the value of S when U equals minus 5, T equals 4, and A equals 10. Now, it makes a lot of sense to find the value of S now, as opposed to the previous question, because S is the subject of the formula. Only once you have the subject of the formula does it then make sense to evaluate the value of that expression, whatever it may be. So always look to make a variable the subject of the formula first before you want to evaluate an expression involving that subject. So S equals U, which is minus 5 times T, which is 4, plus a half times A is 10, and T is 4, so times 4 squared. Now another thing to bear in mind is always use brackets when substituting values into an algebraic expression. Do not use brackets. If you don't use brackets, you're going to run into all sorts of problems, and you'll never get this right. So always use brackets and always obey BODMAS. So S equals minus 5 times 4 is minus 20 plus a half times 4 squared is 16. 16 times 10 is 160. 160 times a half. So let's just put 160 in there now. So that's minus 20 plus half of 160 is 80. So S equals 60. Now we want to make A the subject. Okay, so this is the term here that contains A. A is multiplied by half and it's multiplied by t squared. Just before we continue, another thing I just want to point out. AT squared, when you expand this, is A times t times t. The squared on the t means that we have t times t. If you have at bracket all squared, this means a squared t squared, which is a times t times t. Two very, very different quantities. Okay, just bear that in mind. So coming back to this expression, we have half at squared. So the variable a, which is what you're trying to make the subject, is bound to a half. It's multiplied by half. It's multiplied by t squared. So anything that is not bound to a in its present form, you're just going to move to the other side of the equation. So in other words, this term here, ut, we're just going to move to the left because it's separated by a plus sign. When you have separation of terms, you can simply move terms across the equal sign. So moving ut across to the left, we have s minus ut equals a half at squared. Now, because we have a half multiplied by a multiplied by t squared, let's get rid of the half first. Now, because 2 is a denominator, we have division by 2. To reverse division, we multiply. So we're going to multiply both sides by 2. And just be careful here, we're going to use brackets because it's 2 times s and 2 times minus ut. So we might as well just put 2 times bracket s minus ut. Okay, so on the right, those 2's will cancel. That was the whole reason of multiplying by 2. So we have 2 times s minus ut on the left. And now we have at squared. And because we're trying to make a the subject, we're multiplying a by t squared, in order to reverse multiplication, we divide. So we can divide both sides by t squared now. So on the left, we have 2 times s minus ut all over t squared, and that equals a. Now, a is the subject of the formula because we have a expressed in terms of the other variables there. In this expression over here, s equals ut plus half at squared. S was the subject. We've taken this formula, rearranged it such that a has now become the subject. On the left-hand side over here, it's not necessary to multiply 2 into the bracket because as it is right now, this is the simplest form. Right, everything on the left-hand side, everything here is considered to be a single term because it's just multiplication. We have a set of brackets and we have multiplication and division. So the whole term on the left-hand side is considered to be a single term. If we multiply 2 into the numerator, then in the numerator we're going to have 2 separate terms. It's the same. It doesn't change the expression. It's just not the simplest form of the expression. So this is how we would leave our answer. Okay, question 3. A equals b plus 2 over c. The first part of the question is to make b the subject. Okay, well, let's just see where b is. B is part of the numerator of a fraction. So in order to get b on its own, we're going to have to remove that fraction, right? We need to separate it from from c rather. B plus 2 is divided by c. So to reverse division, we're going to multiply. So we're going to multiply both sides by c, right? So that those will cancel. C times a will give us ac, and on the right-hand side we have b plus 2. Now, we have 2 terms on the right-hand side, separated by plus sign. So it's easy to just separate them because we can just move the 2 across to the left. So AC minus 2 equals B. And now B is the subject of the formula. Okay, now we want to make C the subject. So A equals B plus 2 over C. We want C to be the subject. So it's part of the denominator. Let's just multiply both sides by C again, so that we can remove that denominator. So on the left we have AC, and on the right we have B plus 2. Now because we're looking to make C the subject, we're now going to divide both sides by A. So C equals B plus 2 over A. So as you will have noticed, what we are doing is in order to make a particular variable the subject of the formula, we are just performing reverse BODMAS, or reverse operations rather, not reverse BODMAS. More accurate to say reverse operations. If we Need to reverse addition, we subtract. If we need to reverse subtraction, we add. If we need to reverse division, we multiply. If we need to reverse multiplication, we divide. Given P equals R over T minus 3, we want to make T the subject. Now T is part of a denominator. So the first thing we need to do whenever we have a fraction, and in this case we're looking for the subject or the formula which is actually part of the denominator of that fraction, we're going to remove that denominator. So we're going to multiply both sides by T minus 3. Whatever that denominator is, we're going to multiply both sides by that denominator to remove the denominator. So on the left hand side we have P bracket, P times T minus 3 equals, now these will cancel, which is precisely the reason why we multiplied by T minus 3 in the first place. So P times T minus 3 equals R. Now T is part of this bracket here. We multiply by P. So what we're going to do is we're going to divide both sides by P now, so that we can get T minus 3 on the left, and then on the right we have R divided by P. Now T minus 3 are two terms separated by a minus sign, so it's the minus 3 is not bound to T. So we can just simply move that across to the right hand side. So therefore T equals R over P plus 3. And now T is the subject of the formula. Given D equals 12 over 1 plus the square root of E, we want to make E the subject. Okay. So again, E is part of the denominator of a fraction. So we want to remove that denominator. So we're going to multiply both sides by 1 plus the square root of E. And just remember to always use brackets. Okay, on the right hand side, we're just going to have 12. On the left hand side, we have D times 1 plus the square root of E. On the right hand side, we have 12. Now we can divide by D because this bracket, 1 plus root E, is multiplied by D. And we want to reverse the multiplication, so we are going to divide both sides by D. So we now have 1 plus the square root of E equals 12 over D. Now we have the square root of E plus 1 on the left hand side. They are not bound to each other, so we can simply move the 1 over to the right hand side. So the square root of E equals 12 over D minus 1. Now we're not looking for the square root of E, we're looking for E to be the subject. So I'm just going to move up here. And you can do it down here. So what we need to do now to make E the subject, we need to square both sides. So we're going to square the left hand side. And what we do to the left hand side, we do to the right hand side as well. E. So therefore E equals 12 over D minus 1 all squared. You can leave it in this form, it's quite acceptable. If you wanted to, you could multiply this bracket, but then you're going to get 3 terms. As it stands right now, this expression here, 12 over D minus 1 all squared, is a single term, and this is the simplest form. Again, just to reiterate, if you multiply this bracket out, you're going to get 3 terms, and 3 terms is clearly not the simplest form because a single term would be. So you can leave it as it is. Okay, given b squared equals u squared plus 2as, we are required to find the value of v when u equals 3, a equals 2, and s equals 4. Before we do that, we are just going to make v the subject. Right now, v squared is the subject. We want v to be the subject. Now, v squared is the subject, which means all we really need to do now is square root both sides. So we're going to square root both sides, and that'll give us v equals the square root of u squared plus 2as. Now we can substitute these values for u, a, and s to find the value of v. So we will have the square root of 3 squared plus 2 times 2 times 4 So v equals the square root of 3 squared is 9. 2 times 2 is 4. 4 times 4 is 16. So we have the square root of 9 plus 16. That's the square root of 25. And therefore v equals 5. V equals 5 when u equals 3, a equals 2, and s equals 4. Okay, now we're required to make u the subject of the formula. So if we look at the right-hand side, we have u squared plus 2as. Now, 2as is not bound to u squared, so we can simply just move it over to the left. So v squared minus 2as equals u squared. Now, u squared is the subject. We don't want u squared to be the subject. We want u to be the subject. So we are now going to square root both sides. And therefore, u equals the square root of v squared minus 2as. Just to reiterate again, you may not square root over a plus or minus sign. So this is your final answer. U is now the subject of the formula. If you want to make S the subject, we look at the term that contains S, which is 2as. So S is multiplied by 2a, but everything else is not bound to s. So we can move u squared across to the left-hand side. So v squared minus u squared equals 2as. I'm moving the u squared across to the left because 2as is already positive. You want to keep your answers as positive. You don't want negatives. So we're just going to be moving u squared to the left. Now we have 2a times s. If we want to isolate s and make s the subject, we divide both sides by 2a. So therefore, v squared minus u squared over 2a equals s. And now s is the subject of the formula. Given t equals 2 pi times the square root of L divided by G. We're required to make L the subject. Now let's just first identify and see where L is. L is part of a fraction number 1, but it's also underneath a square root bracket. Okay, so anything that is not part of that square root bracket or that fraction, it doesn't involve L. We are just simply going to isolate, we're going to remove from that square root bracket. So because 2 pi is multiplied by the square root bracket, we're going to first divide by 2 pi. We divide both sides by 2 pi to remove 2 pi. So t divided by 2 pi equals the square root of L divided by G. Now, looking at the fraction L divided by G, we can't do anything with it yet because it's still tied down and bound by the square root bracket. So to remove that square root bracket, we now are going to have to square both sides, because squaring a square root is the reverse operation that we need to perform. When you square a square root, you're essentially cancelling out that operation, that square root bracket. So we have t divided by 2 pi all squared equals L divided by G. Now we can look at the fraction, because there's nothing binding or holding that fraction together. We can simply multiply both sides by G now to remove the denominator. So on the right, the G's will cancel, so we now have G bracket T over 2 pi all squared equals L. L is now the subject of the formula. Next, we're required to show that G equals L times 2 pi over T all squared. So we want to make G the subject of the formula. So at this point, we have G times T over 2 pi all squared equals L. If you want to make G the subject, G is simply multiplied by this bracket squared. So we're just going to divide both sides by that bracket squared. Right, so we now are going to have G equals L divided by T over 2 pi all squared. Now, whenever we divide by a fraction, you can change the division sign into a multiplication sign by reversing that fraction. In other words, we're going to tip in time. So we have L over 1 times 2 pi divided by t all squared, which if we just write in an eta form, G equals L bracket 2 pi divided by t all squared. And that is precisely what we were required to show. So G is now the subject of the formula. Given D equals pi uppercase R squared minus pi lowercase r squared, we want to make uppercase R the subject. So we just identify where uppercase R is. It's part of this term here. First of all, uppercase R is squared and then it's multiplied by pi. So anything that is not part of that, we're just going to move to the other side of the equation. So we're just going to move minus pi lowercase r squared to the left. So D plus pi lowercase r squared equals pi uppercase r squared. Now because we're looking to make uppercase r the subject, we're going to divide both sides by pi, because pi is multiplied by uppercase r squared. So to reverse that multiplication, we're going to divide. So D plus pi lowercase r squared divided by pi equals uppercase r squared. Now r squared is the subject. We don't want uppercase r squared to be the subject. We want uppercase r to be the subject. So we are now going to have to square root that square term. What you do to one side, you do to the other side. So we're going to square root the left hand side as well. So the square root of D plus pi times lowercase r squared divided by pi equals uppercase r. Uppercase r is now the subject of the formula. We now want to make lowercase r the subject. So the term that contains lowercase r is that term over there. So anything that is not part of the term, we're just going to move over to the other side of the equation. Now just bear in mind we have a minus sign over here. So we don't want to make our subject negative. So we're going to take this entire term minus pi lowercase r squared over to the left. So we will have pi lowercase r squared plus d equals pi uppercase r squared. Now we can then move plus d over to the right hand side. So we get pi lowercase r squared on its own, and that equals pi uppercase r squared minus d. And now divide both sides by pi, because we're multiplying lowercase r squared by pi. So to reverse multiplication, we divide, and therefore r squared equals pi uppercase r squared minus d divided by pi. And just coming up here, we now are going to square root both sides because we have a square on the left. So we have the square root of pi uppercase r squared minus d divided by pi on the right, and therefore r equals the square root of pi uppercase r squared minus d divided by pi. Lowercase r is now the subject of the formula. Okay. Finally, we're required to make pi the subject. Now, on the right hand side, we can clearly see there are two terms that contain pi. Pi times uppercase r squared and pi times lowercase r squared. So because pi is the same quantity, we need to make pi the subject. Here we are going to factorize, right? So we're going to take out a common factor of pi such that we have pi times uppercase r squared minus lowercase r squared. We've isolated pi by taking out a highest common factor on the right hand side. Now to get pi on its own, because pi is multiplied by r squared minus r squared, we're going to divide by uppercase r squared minus lowercase r squared. What you do to the one side, you must do to the other side. So therefore, d divided by uppercase r squared minus lowercase r squared equals pi. And pi is now the subject of the formula. Generally speaking, the subject of the formula is always written on the left-hand side of an equation. It's not going to make any difference whatsoever we're just writing pi on the left and whatever else on the right hand side. It's just a convention and a notation to express the subject of the formula on the left hand side of the equation. We're given 3x squared minus 4y squared equals 11. We're required to find the value of x when y equals 4. Again, if the follow-up question is make x the subject, it's a bit of a nonsense question. It's far easier to make x the subject first and then find out what the value of x is given the value of y. So we're going to start with b. So the term that contains x is this term here, 3x squared. Anything that is not part of that term can simply move to the other side of the equation. So minus 4y squared, we're going to move to the right. So 3x squared equals 11 plus 4y squared. X squared is multiplied by 3, so the next thing we do is divide both sides by 3. Then we have x squared equals 11 plus 4y squared over 3, just coming up here. You should be writing those vertically. You should not be writing horizontally at all. Lay out your work in a very logical manner by writing each line underneath the previous one. Now, to get rid of, because we have x squared, we're going to square root both sides. So the square root of x squared equals the square root of 11 plus 4y squared over 3. Therefore, x equals the square root of 11 plus 4y squared over 3. Now it makes sense to evaluate x when y equals 4. So when y equals 4, x equals the square root of 11 plus 4 times 4 squared divided by 3. So it's going to be the square root of 11 plus 4 squared is 16 times 4 is 64. That's all over 3. So x equals the square root of 11 plus 64 is 75. So root 75 over 3. 75 over 3 is 25. So x is the square root of 25 and therefore x equals 5. And finally we want to make y the subject. So now we want to make y the subject. So the term that contains y is minus 4y squared. So anything that is not part of that term, we're just going to move across to the other side. Now just bear in mind that minus 4y squared is minus. So we want to make that a positive term. So we're going to take this term across to the right hand side. So 3x squared equals 11 plus 4y squared. Now we want y to be the subject. So now we're going to take 11 across to the left. So 3x squared minus 11 equals 4y squared. We want y to be the subject, so we divide both sides by 4. So 3x squared minus 11 over 4 equals y squared. Y squared is the subject, but we want y to be the subject. So now we're going to square root y squared, which means we square root everything on the left hand side as well. So the square root of 3x squared minus 11 over 4 equals y. Y is now the subject of the formula. Given t equals 2 times the square root of a over c plus 3. We want to make a the subject of the formula. So if we just look where a is firstly part of a fraction, but it's also bound by a square root bracket. So we are going to need to remove that square root bracket. But before we do that, we need to remove this 2. This 2 is multiplied by that square root bracket. So we're going to divide both sides by 2 first. So t divided by 2 equals the square root of a over c plus 3. Now, before we can worry about the fraction, we need to remove the square root bracket, which means we're going to square both sides. So we're going to square the left and we square the right. Just moving up here. Again, you're going to be working vertically, not sideways. there's just obviously I have a lack of space here, which is why I'm moving to the side. So we have t over 2 all squared equals a over c plus 3. Now, we are looking to make a the subject, which is in the numerator of this fraction. So we're now going to multiply both sides by the denominator, c plus 3, to remove that denominator. So we have t over 2 all squared times c plus 3 equals, c plus 3 will cancel, and that gives us a. A is now the subject of the formula. You can leave it like this because everything on the left-hand side is a single term. We have a bracket, t over 2 all squared, times another bracket, c plus 3. Everything on the left is considered to be a single term. This is as simple as it gets. This is the simplest form for A being the subject. Okay, we now want to make C the subject. Again, C is now part of the fraction that's in the denominator, and it's also bound by that square root bracket. So the first thing we're going to do again is just divide both sides by 2, so that we can just isolate that surd, that square root bracket. We now, to remove that square root bracket, have to square both sides. So t over 2 all squared equals a over c plus 3. So we're going to multiply both sides by c plus 3. So we have c plus 3 times t over 2 all squared equals a. Now we want c to be the subject, and c is part of this bracket over here, and now it's multiplied by t over 2 all squared. So we are going to divide by t over 2 all squared. So now we will have c plus 3 on the left, and that equals a over t over 2 all squared. Now, whenever we divide by a fraction, we change the division sign into multiplication sign by inverting that fraction. So we'll have a over 1 times 2 over t all squared. So c plus 3 equals a 2 over t all squared. And now this 3 over here is separate from c, so we can just move it across to the right. So therefore c equals a times 2 over t all squared minus 3. C is now the subject of the formula. A squared equals b squared plus c squared minus 2bc uppercase t. We want to make t the subject of the formula. So first let's identify where t is and what's holding it together. We have this term here, minus 2bct. Anything else that is not part of this, we can simply move across to the other side of the equation. Just notice that this is a negative, and you want to make the term that contains the subject positive. So we're going to take this entire term to the left-hand side. So 2bct plus a squared equals b squared plus c squared. Now a squared does not form part of the term that we want to find the subject of the formula for. So we're going to take a squared over to the right hand side. So 2bct equals b squared plus c squared minus a squared. Now we want t to be the subject. So we're going to divide both sides by 2bc because we're multiplying t by 2bc to reverse. So to reverse multiplication, we divide. So we divide both sides by 2bc, and therefore t equals b squared plus c squared minus a squared over 2bc. T is now the subject of the formula. Okay, given the formula u v equals fu plus fv, Find the value of f when u equals 20 and v equals 30. Again, this is a nonsense question. Well, it's not nonsense, but I mean, it doesn't make any sense because the second question wants you to make f the subject, and the first question wants you to find the value of f. So it always makes sense to make the subject, to find the subject of the formula first before you try and evaluate or find a value for that subject. So we're first going to do b. So the two terms that we have that contain an f are these terms, fu and fv. So to make f the subject, we are first going to factorize, take out a common f on the right, and we have f times u plus v. Now, to isolate f, we divide both sides by u plus v. So uv over u plus v equals f. F is now the subject of the formula. Now it makes sense to find the value of f given u equals 20 and v equals 30. So f equals uv over u plus v. So when u equals 20, we'll have uv being 20 times 30 divided by 20 plus 30. So that would be 600 over 50. Therefore, f equals 12. Okay, we now want to make u the subject of the formula. So all the terms that contain a u need to be on one side of the equation. We have a term on the left, uv, and we have a term on the right, fu. We need to get these two terms on the same side of the equation. So we're first going to move fu over to the left. So uv minus fu equals fv. We can now take out a common factor of u on the left, okay, because we're trying to make u the subject of the formula. So u times v minus f equals fv, and now we can divide both sides by v minus f. So therefore u equals fv divided by v minus f. U is now the subject of the formula. We now want to make v the subject of the formula, so the terms containing v are on the left, uv, and on the right it is fv. We need to get these two terms together. So we're going to take this term fv over to the left, so uv minus fv equals fu. We now need to isolate v from these two terms, so we're going to factorize. So v times u minus f equals fu. Just coming up here, we're now going to divide both sides by u minus f to make v the subject of the formula. So v equals fu over u minus f. V is now the subject of the formula.